Hello, and welcome to The Delight of Composition. I'm Timothy W. McDunn. Thanks so much for joining me. Today we're talking about a tool called a Markov chain, which was famously applied to music by the engineer-turned-composer Iannis Xenakis. In this video, we'll make use of Dmitri Timochko's voice-leading spaces, which are known to mathematicians as orbifolds, and to music theorists as that thing Timochko talks about. You can read more in his magnificent book, A Geometry of Music. We'll explore how Markov chains connect human technology to nature in a beautiful and poetic way. In probability theory, a Markov chain is a sequence of random events in which the probability of the next event depends on the state of the current event. Let's use this tool to pick notes from the pentatonic scale. First, we have to draw a two-dimensional matrix. Then we'll write notes of the pentatonic scale on both axes of the grid. The notes vertically on the left side of the grid will represent the current note that's being played, and the notes horizontally on the top of the grid will represent potential next notes. In each box, I'll set a transition probability to control how likely my melody is to move from one note to the next. I don't want any repeated notes, so I'll fill the diagonal with zeros. The next box will represent the probability that a D follows a C. Let's say I want a lot of stepwise motion, so I'll set this probability pretty high. Fill in the rest of the boxes and see what it sounds like. I know what you're thinking. What would the Barnsley fern sound like? Well, let's project it into one of Timochko's orbifolds, like you do. The fern is defined using a series of affine transforms. This means that taking a point xy, we multiply by a matrix. X and y get multiplied by the first row of the matrix, then by the second row of the matrix. Then we add a constant to each of those, and we get a new point. So each point depends on only the previous point. It's a Markov chain. We could also snap the notes to members of the pentatonic scale. Make the range a little bigger. Switch to the diatonic scale. Nature is full of beautiful and complex mysteries. How do animals decide when and where to migrate? Or how does the weather decide how to change? I know it doesn't really decide anything, but how does it change, right? And how does DNA mutate, right? Markov chains encapsulate lots of these mysteries, which is what makes them such a powerful natural metaphor to apply to music. Legend has it, when Xenakis studied with the 20th century French composer Olivier Messiaen, Messiaen told him something to the effect of, "Your harmony and counterpoint are a disaster, but you're a great engineer. Apply that to your music." Xenakis did this and composed some of the most influential music of the 20th century. What made Messiaen a great teacher was that he recognized the unique gifts of his students. Not everyone fits the mold of a traditional composer, but anyone can compose, absolutely anyone. For my Markov exercise, I'm going to use two marvelous scales. I'm going to use the pentatonic scale, and then I'm going to use this other scale that's kind of like a mixture between the pentatonic and the whole tone scale. Now these two scales have 3 common tones between them, actually 4. So it makes a lot of sense to move from one to the other. And I'm just going to create sort of a sequence of different scales, starting with this one, moving to that one, and then finally we'll get to another transposition of our wonderful pentatonic scale. Alright, so we've moved between 2 different pentatonic scales with 1 scale in between, and every time we just move 1 note at a time. I'm inspired here again by Dmitri Tomaksko's wonderful book, A Geometry of Music. And when I look at this sequence of scales, one thing I notice is that each of the scales has 3 notes in common. All of them have D and E and A, right? So I think I'll take advantage of that, and I'll have this interesting transformation going on in the background with my Markov chain, and then my melody is going to be based on this quintal chord. This is actually a quintal chord because I could stack each of these notes in fifths. So I'm going to write my melody for electronic wind instrument. You use whatever instrument you want. I'm going to leave lots of space with fermatas. And I'm just transforming this one little cell. And so while this is happening, I'm going to go through these 3 different scales, and then we'll do the same thing at a couple of different transposition levels. So there's 1 transposition of that chord, but I'm going to embed it in a larger phrase. And let's add some slurs. Just a couple of slurs in here. This will make it real smooth and lyrical. And then I'm going to go back roughly to where I came from, but you can't set foot in the same river twice. Let's make it just a little different the second time around. Just a little different. And we'll end unresolved. Let's add a little expression, just a little expression. And the wonderful thing is the electronic wind instrument has so much expressive range. To create our Markov piece, let's just install this software called Super Collider. There's a link in the description. Now let's just download this little starter patch I wrote for us. The patch selects notes from a scale using a 2-dimensional Markov matrix. The first thing you're going to need to do is click anywhere inside this big block of code at the top and press Command Return or Control Enter. This executes the whole block of code, which starts up the Markov processes in 6 different octaves. To actually hear the processes, we have to resume them. Hit Command Return or Control Enter while your cursor is on that line of code. So now we start to hear the Markov process in one of the octaves, octave 2. Or we can run all of them all at once. I can set the scale and produce different colors. I could switch to the Dorian scale. And I get a different color. So you see how we're controlling the bigger picture of what's going on without writing each note individually. And I can also play with the transposition. And I could also control the register of the whole texture using the mouse. So I could control the lowest note with the mouse. Now as I go up the screen, the texture goes up. And I can create these expressive shapes with my mouse. So the way we're going to actually write a piece is we're going to write lines of code that create a setting that we're interested in. Just surround all of your lines of code in 2 parentheses like this, an open and a closed parenthesis. Label it with a comment. I'm calling it Q7. Hit Command Return or Control Enter. And we jump right to that arrangement of the texture. Write the cues, copy it into Dorico. Be sure to share your own Markov exercise at the Delight of Composition landing page. I made this space for rich and vibrant discussion of technique. Link in the description.